We are live and we're recording. Welcome back to the exam walkthrough. This is going to go into the oscillation playlist. 2024 October Unit 5, question 13. We can do the question. And if you want to go for the examiner report and the mark scheme, check the end of the video. So, let's start this question. It was 5-marker question and a bit of a tricky question, so we'll try this one. Let's go. So, there's a lot of information given, but in a nutshell, you have this diagram here. That's the main thing. And you have two pendulums. In the first one, you have the length L, and the second one you have length L by 2. And then both of the pendulums are displaced and they oscillate. And then the student suggests that the maximum kinetic energy of the pendulum with length L by 2 will be 4 times the maximum kinetic energy of the pendulum with length L. So basically, it would look something like this. So the kinetic energy at maximum of the pendulum with the length L by 2 will be 4 times the kinetic energy, maximum kinetic energy of the pendulum with length L. So we have to verify if this is true or if this is not true. So we put a question mark next to it. Okay? So I have to get the question. And now one of the major things you have to understand, a couple of relations, is that Ke max is equals to half mv max squared. That's the first thing. When the velocity is maximum, that's when the kinetic energy will be maximum. The mass will not change. The second thing you have to remember, formula, is velocity Vmax is equal to the amplitude times the omega value. Okay? So these are the couple of things you have to keep in mind. Now we know T is equals to 2 pi square root L over G. Okay? And then what we're going to do here is we're going to say T is equals to 2 pi over square root G times square root L. And then we can take all of this as X. So we can say T is equals to X square root L. And then I can make this relation that T old divided by square root L is equals to T new, which is the new time period, when the L is half of the original one, so L by 2. And then we can get this relationship. Okay? And then what I can do here is then I can cross multiply. And I can see here the square root L will cancel out. And then I can see here the new time period will be equal to the old time period divided by square root 2. So I hope till here it's clear. And then what I can do here is I'm going to flip both things. So I'm going to say 1 over T new is equals to square root 2 T old. And I can say the new frequency is equals to square root 2 old frequency. I think it's easier to work with frequencies. So I'll just take that approach. Okay? You can work with the other one as well. That's totally fine. And now we come back to our original thing here. Now why did I do all of that? Is because now I can say the Vmax is equals to A 2 pi F. Remember? And all of this is constant. So again, I'm going to take it as X. So Vmax is equals to XF. Okay, I hope that's clear. And then I can say Vmax old is equals to XF old, frequency old. And then Vmax new is equals to X square root 2 frequency old, because that's equals to the new frequency. So instead of the new frequency, I'm going to write square root 2 the old frequency. And then we take both equations, and what we do is I'm going to divide both the equations, this equation and this equation. This is going to cancel out, and then I cross multiply both things. And then after I cross multiply, I'm going to get this as my expression, and then I cancel the old frequency out, and I'm going to get the new maximum velocity is square root 2 times the old maximum velocity. So let's find the new kinetic energy. So Ke max new is equals to half m square root 2 v max old squared. New maximum velocity, I wrote it in terms of the old maximum velocity. And then I can write the Ke max old is equals to half m v max old squared. Okay, and then I'm going to simplify this further. and I'm going to get this. So the square root 2 becomes 2, and then the Vmax old square. Okay, so I've taken this Vmax new and I've just plugged it in over here, and instead of writing Vmax 2, I've written square root Vmax old. And then I've written the old thing, the old kinetic energy maximum, and the new kinetic energy maximum. And now I can see here that, notice, half m Vmax old square. Instead of writing this, which is the same thing as this right over here, I can write Ke max old. So I can substitute. So Ke max new is equals to 2 times Ke max old. Okay? Now, the person says that the maximum kinetic energy of the pendulum with length L by 2 will be 4 times the maximum kinetic energy of the pendulum with length L. And we can see here, this is the pendulum with length L by 2 and L. And we can see clearly that the maximum kinetic energy is just 2 times more than the previous maximum kinetic energy. So after doing all of this, we can say that the student's suggestion is incorrect. So we can write here, the student's suggestion is incorrect. And that's your answer. So I hope this was clear. If you have any doubt, you can comment. And now I'll show you the examiner report and the mark scheme.